Hello everybody, am I audible to you? Anji, I hope that I am audible to you. Please let me know. I hope that everybody is able to hear me out. Yeah, good evening Anushka, am I audible to you? Am I audible, guys? So I think guys, from my side it's clear, but still if you have any problem you can ask, right? Okay. Also tell me that who is watching me live. Good evening Anushka, Askar, very good evening to all of you. Please let me know, guys, that who is watching me live. Who is watching me live? Okay, so there was a problem in my system yesterday. That's why I couldn't start the class. I tried for something 1 hour. I tried, but it was not possible to start the class. That's why I couldn't take your class, guys. Right? But yeah, today we will resume our topic and let's start the topic, guys. That let's revise the previous content which we have studied. Okay, so last time we were discussing the very important points, like in the lecture number 12 we have discussed the tank system having one outlet, but in the previous lecture we started, or you can say we have completed, two outlet system. The as you know that our task is to find out the transfer function, and that is a very simple. Like in the one single input single output system, Kp is my R. Here the difference is only that my Kp is my R equivalent. Okay, and R equivalent means the equivalent resistance offered by the two streams, and as you know that in the tank system those two streams are connected through the parallel connection, right? Kind of parallel connection. Okay, so how to find out the R equivalent in the parallel connection, we have knowledge about that. Okay, after that we have discussed example based on it. After that we have discussed the mixing tank, and in the mixing tank we found that tau p is basically V divided by Q. Q is my flow rate. Actually, flow rate means the volumetric flow rate. Okay, do not confuse in that. This is my volumetric flow rate. Volumetric flow rate means it is my meter cube per unit time. Okay, whether it is second, minute or hour, and this is my volume. This is my volume, and Kp is 1. In the energy storage tank we have calculated that my tau p is mc upon ua and my Kp is equal to 1. So if you will figure out, guys, and you can also remember these things like that. Okay, that if we will talk about the mercury thermometer, in that also my Kp is equal to 1, yes or no? In my your mixing tank, Kp is equal to 1. Energy storage tank, my Kp is equal to 1, है ना? Okay, in the your liquid level tank, my Kp is equal to the R, okay, and if 2 outlet is there, then Kp is equal to my R equivalent, right? It is clear to you? So these are the basically thing which we discussed, right? So these are the things which we discussed previously, okay? So here very important point is that till now we have defined the tau p as capacitance into the resistance. Mean in this system there is a capacity term and there is a resistance term. It means that system has both the qualities, right? Means to hold something and to resist something, okay? So this is the quality of this system. Now please put the heading, the sixth type of the example, that is pure capacitive system, and it is important and it is quite different from the, you can say, the previous examples. So please put the heading pure capacitive. Please put the heading pure capacitive. Pure capacitive system. Okay, what is the meaning of pure capacitive and what systems is comes under the category of pure capacitive system? Let's understand this. So there is a tank, okay, there is a tank, and this is the input of the tank, and this is the output. This is the output, right? And again we have to maintain the height of this tank as h. It is clear to you? And the cross sectional area is A. Okay, input flow rate is my Qi. Now just try to understand it. From this tank I want the constant flow rate. Means my output flow rate must be constant. For that purpose we have applied we have, you can say, installed a pump, and this pump is basically constant displacement pump, or you can say this is my constant discharge pump. Means that this pump basically give me the flow rate constant. Okay, this pump will give me the constant flow rate. So Q naught will be constant. Okay, QI can be changed regardless of the QI. I am getting Q naught all the time. I am getting outlet discharge Q naught all the time. Okay. So in this system, my main aim is to basically, here also my main aim is to keep the output, or you can say keep the height at h. Okay. So we have to maintain the height of the tank, height of the liquid level, or you can say height of the liquid as h. This is my aim, right? Again, as you know that if we are dealing with the level, then we have to do the mass balance. Okay. So for that purpose, I think there is no need to write again and again all the terms that density is constant. Okay, so density is vanished from the your equation, and can I write directly this, that my input flow rate minus my output flow rate is equal to A into dH divided by dt. I write this equation directly because multiple times I write the equation from the basics. Okay, so this is the equation at any time t. But still, if you have any problem, guys, at how I write this, then you can ask. Okay, done. Now if I write this equation at the steady state, can you guys tell me that what should I write the equation at the steady state? Please think about it. Please think about it. I hope that you have now some idea in your mind. Just compare that idea, that inlet flow rate at the steady state minus the outlet flow rate at the steady state is equal to A d, height at the steady state divided by dt. This is my equation number 2 and this is at the steady state. I mentioned a point here already that this pump is my constant displacement pump, that all the time I'm getting Q naught discharge. It means at the steady state itself I'm getting the discharge, outlet discharge as Q naught. So at the steady state itself I'm getting the Q naught discharge, yes or no? Okay, input flow rate can be changed, right? Because input flow rate is the can be changed with respect to the time. I have both the equation. I know that in the next step, yes, very good, Anushka. In the next step that I have to cancel all these terms to make the, you can say, to make the deviation variable. So Q naught will be cancelled. Now I can write that Q naught is equal to A and it is dH divided by dt. This is my equation number 3 and this is equation in terms of deviation variable. I hope that it's also clear to you. Okay. No, I think I should not write here not, because not is for outlet, so it is only Q. Okay, and for your information, Q is equal to Q inlet minus Q inlet at the steady state. Okay, don't confuse. After the Laplace, it is my QS is equal to ASHS. Okay, and what is the transfer function? Okay, let me write this in the next slide. Output will be my height of the tank divided by input flow rate, and that is equal to 1 divided by A into S. Okay, and I will write it as 1 divided by A divided by S. Okay, and I will write this term as HS divided by QS is equal to, this is my Kp and this is I'll write Kp dash divided by S. Okay, or also you can write this as, you can write also this as, okay, do not confuse, ऐसे ही लिखेंगे हम इसको, don't write like that. Okay, I don't want that will get confused. Okay, so in this case also my Kp is equal to 1. My Kp is equal to 1. Please write this transfer function and then we will move forward. We will discuss about this, that what is the case here, okay, and how we define how this system is different from the others. How this system is different from the others, we will discuss about that. So, but meanwhile, just write this transfer function. Once you're done with this, let me know. Okay, if you want the next slide also, then also tell me. Once you're done with this, please let me know. Okay. Now I hope that you note it down. No, KP is now we can define this system this also, that by keeping KP is equal to 1 by A. Okay, in some of book it is defined as 1 by A, but in some of book it is defined, it is explained in different way. Okay, so I will, because I want you to understand one thing, that's why I write this KP is equal to AS, and here I'm making that KP is equal to 1. Here I'm making KP is equal to 1. Okay, now we will try to understand one thing here. What is that? First of all, if you figure out that, see, transfer function is a very, very important relation, and in the transfer function, by seeing the transfer function, I can tell that what is the order of this, what is the order of the process. Let's suppose I have a transfer function, right? And see the denominator and see the power of the s in the denominator, the maximum power of the s in the denominator. That will be the order of that system. Like in the first order system, my transfer function is in that Kp divided by tau ps plus 1, and here s power is 1. S power is 1. So this is my transfer function for the first order system. For the second order system, it will be 2. For third order system, it will be 3. Okay. The previous 5 examples is related. If we will see the transfer function of the previous 5 examples, then this is the general format for that. Kp divided by tau ps plus 1. And if we have any transfer function, then to calculate the value of Kp and tau p, we have to first convert that transfer function in this kind of format. Means plus 1 should be there. Huh? Plus 1 should be there. Okay. If I'll give you the very quick example, then what I'm saying, I'm trying to say this. I'm trying to say this, guys. Like I have a transfer function. Transfer function is equal to 5 divided by 10s plus 15. And the question is find out the Kp and find out the tau p. You cannot say Kp is equal to 5 and 10 is tau p. No. Why? Because this is not plus 1. It is my 15. It is my 15. So what to do? Just divide the whole equation, denominator and numerator, by 15. It is now 1 by 3. Divided by it is my 2 by 3 s plus 1. Now this is converted into the Kp divided by tau ps plus 1. Now you can compare. Kp is 1 by 3 and my tau p is by 2 by 3. This plus 1 term should be there. This plus 1 term is very, very important. So till those 5 examples, I have Kp, tau p, s plus 1. But here plus 1 term is not there. Yes or no? Plus 1 term is not there, right? Plus 1 term क्या है? गायब है यहाँ से. Okay. So if I define the tau p of this is, and if the power of the s is 1, then it is my first order. So it is for sure that this is my first order system. But it is the different type of the first order system as compared to the 5 examples. In what context? See, its tau p is equal to now A. What is A? A is my cross section area. And what is A signifies? A signifies the capacitance of the system. So here if I'll define the tau p, guys, then it is my only capacitance. This tau p is only the capacitance. There is no resistance at all. There is no resistance at all. But if you will see the previous examples, then in all the 5 examples we define as tau p is equal to capacitance into the resistance. Means the system has both the qualities, capacitance and resistance. Means it is system has the ability to, you can say, gain something, or you can say to hold something, and also there is a resistance term which helps the system to control, right? This resistance term, like in the liquid level system, this resistance terms is related to the resistance of the wall. It is clear to you or not? So as you know that through this wall we can maintain the height. If I'll let's suppose this resistance is infinite, means there is no you can say flow rate in the outlet stream, then this tank may be in the condition of overflow. Yes or no? So the resistance term is very, very important to control the system. The resistance term itself is very, very important to control the system, right? So here in this system, pure capacitive system, transfer function is my Kp divided by As. It is my first order, but it has only the capacitance. That's why it is called a pure capacitive system. That's why it is called pure capacitive system. I hope that it is clear to you. I hope that it is clear to you. It has only the capacity. It has only the capacitance. There is no resistance. There is no resistance at all. If there is no resistance at all, then what is the, you can say, repercussion of this? So we will see the repercussion of this also. I am clear with this or not? Okay. Till now, whatever we calculate the response, that response is basically for the transfer function Kp divided by tau Ps plus 1. Okay, now let's try to calculate the response for the unit step input or step input in the case of pure capacitive system. Okay, now what is that response? Let's try to understand it. Okay, response is for the unit step. Let's see the unit step response. Let's see the unit step response. Unit step response means what is the input value here? Input value is my 1 by S. Okay, and what is my GS? My GS is equal to 1 divided by AS. Okay, done. And here my A value is my, sorry, here my magnitude of the step input is my 1. Okay, it is clear to you or not? Now, if I'll write this, I can write it as 1 by A divided by S to make it simple. And what is my YS now? My YS is equal to, uh, 1 by A divided by S multiplied by 1 divided by S. Okay, it is clear to you. My Kp is 1 and I defined that my Kp dash is 1 divided by A to make it this term simple. Okay, my Kp is equal to 1, and if I divide the 1, then I write this constant term as Kp dash. Kp dash is nothing but it is a constant. Okay, don't you can say confuse in this. So my Ys is equal to Kp dash divided by S square. If you will take the Laplace inverse, and if you find out the Yt, then what is it? Kp dash is my Kp dash which has the value of 1 by A. It is constant itself. 1 by S square Laplace is T. So what is my Yt? Yt is my Kp dash into T. Kp dash into T. I hope that it is clear to you. I hope that it is clear to you. Yes or no? If you will try to plot the graph between Yt and T, then what kind of graph you will get? It is very simple, that you have the straight line equation of kind of y is equal to mx kind of equation, right? That line is passing through the origin and it is something like that, and the slope is basically constant, that is my Kp dash. Clear? It is clear to you or not? It is clear to you or not, right? So what you can figure out from this graph? What you can figure out from this graph? Can anybody tell me? Can anybody tell me that what you can figure out from this graph? What this graph signifies? Please tell me. Please tell me. Unbounded response. Okay, great. Great. So this kind of graph we get in the ramp input, if you remember. See, it means as time goes on, like if I'll check the response for this time, then this is the response. Not ramp input, no ramp input. Input is unit step beta. Ramp input is different thing. I got the response for the unit step input for the pure capacitive system. At this time, my input is increased and my output is increased, and now this is the value. So it means as the time increases, the value of your output will be increases. Yes or no? It is yes or no? It is clear or not? It means that it is my kind of unbounded response I'm getting. Means my system is not controllable at its own. My system is not controllable at its own. Why? Because there is no resistance term at all. What I'm saying that if you find out the value of final value of this system, of this output, then it is so obvious that is my Kp dash T. If you will put T tends to infinity, then what is the value? Value tends to infinity. What is this? This output is the unbounded. Output is my unbounded. Output is unbounded. It means that my system is going towards the unsteady state. System has no capability to get back to its steady state at its own. खुद अपने आप खुद ये steady state पे नहीं आ सकता. So it is not possible for the pure capacitive system to get back its steady state itself. It is clear or not? So the response for the pure capacitive system for the unit step input, it is my unbounded. Okay, so if you see here, then till the 5 example, there is you can say the case is different. I'm getting the Kp is equal to tau ps plus 1. In the tau p, I can see the both the terms capacitance into the resistance. And all those 5 examples are related to the first order, and for the first order, response of the step input will be bounded. We already checked that. But if we check the unit step input response for the pure capacitive, then it is unbounded, but still it is first order. Then I can say, then I can make a conclusion about it that first order system has two types. There's two types of the first order system. One is my called self-regulating, and another will be my non-self-regulating. Self-regulating means those system which can regulate itself, which has the you can say ability to gain its steady state again by its own. And self-regulating system transfer function is like Gs is equal to Kp divided by tau ps plus 1, and here tau p is defined as for this capacitance into the resistance. So this self-regulating system has the resistance term itself, and this resistance term is responsible for the self-regulation. But for the non-self-regulating system, my transfer function will be 1 divided by As, and here my tau p has only the capacitance. There is no resistance at all. If there is no resistance, then it is difficult for the system to achieve its steady state again. Because यार सिंपल सी बात है, एक बात बताइए मुझे, you are in the young age, let's suppose, okay, you are now mature enough guys, okay, but let's suppose we are in the 10th class, 11th class, है ना, we all at this age the students are you can say little bit थोड़े से अलग फेज में रहते हैं ना, समझ रहे हैं आप, मतलब अलग फेज में रहते हैं, means that they want freedom, right, they don't want to interference of anybody, है ना, even the parents interference is not we can say they want, right, so right, so self-regulating means that let's suppose, okay, I can do anything, but if my father is at home, my father is at home, then little bit there is a, you can say, fear that okay, I can do anything, but I can do in limit, because there is a resistance term, है ना, so we are in the controlled state, I say, है ना, I can say that I'll be in the controlled state. But if there is no resistance at all, let's suppose that my father is not at my home, now we are free, because मम्मी से तो हम डरते ही कहाँ हैं, उनसे तो इम्यून हो जाते हैं हम, पता है मम्मी खींच के थप्पड़ लगा भी देगी तो हमें दर्द नहीं होने वाला है, यस और नो, है ना, सो जो डर होता है, एक फियर होता है, दैट इज ओनली फ्रॉम द फादर साइड. So if that resistance term is not at our home, then we are in the uncontrolled state, है ना, हम सिबलिंग से लड़ते हैं, जब आके लड़ते हैं, कुछ भी करते हैं, उस स्टेट में जब हम बच्चे होते हैं, चाइल्डहुड में. ओके, सो दिस इज द काइंड ऑफ द थिंग्स व्हिच आई एम ट्राइंग टू एक्सप्लेन यू. If it is clear, then tell me and I'll move forward. Now, in the previous examples, like whatever we discussed, this liquid level tank system, we assume that this Q is basically equal to H by R. Means it is our assumption that Q is, means it's our assumption, or you can say in the most of the cases it is something like this, that Q is directly proportional to the H and Q is inversely proportional to the R. This is the general assumptions, and this is the general thing, you can say that this is the relation of the Q, H and R. Okay, or you can say that this is the relation between the Q and H. But it may be possible that intentionally we design a control valve that the relation between the Q and H is different from this. Okay, Q is directly proportional to H. This is the linear relationship between the Q and the H. Q is directly proportional to the H is the linear relationship between the Q and H. It may be possible that there is no linear relationship between Q and H. There is something, you can say, different kind of control valves are there. So now we will discuss that. So please put the heading non-linear valve. Non-linear valve. If non-linear valve is there, then what will be the transfer function? Okay, what will be the transfer function? I have to maintain I have the liquid level tank, and my output flow rate is Q is related as H by R. Then I know how to find out, or you can say what is the transfer function. But what if that Q is not directly proportional to the H? What if it is Q directly proportional to the under root H? In that case, what is the transfer function? That we will try to find out. Okay, so let's try to understand it. Let's try to drive it. I hope that your case is clear to you. The case is clear to you. So what I'm saying that And this topic is important, guys. Okay, this topic is important. This is my input flow rate, and this is my output flow rate, and this is the control valve, right? And this is my Q naught. Again, I want to maintain the height as h. But now my Q is not equal to h by r. It is my Q is directly proportional to under root h. So the relationship between Q and h is non-linear. That is my non-linear. Okay. So now Q is directly proportional to the under root h. So by removing this proportionality sign, I can write Q is equal to C under root h. Okay, C is my any constant. Okay, C is my, okay. Now what is basically requirement here, how we solve this? So first of all, in the, as we know that this system, this tank system is my first order system. To model the first order system, we have to use the first order differential equation. So we cannot put any non-linear term in that differential equation. I have to put only the linear equations in that differential equation. So it means that I have to do the linearization of this function, right? I have to linearize this function, this under root h. I have to first linearize that. After the linearization, I will put that value into the first order differential equation, and I will follow the same steps. Now, how to linearize that? With the help of the Taylor series. Taylor series is a kind of a mathematical tool which has basically linearized the non-linear terms. Now, what is my you can say Taylor series? So basically, the Taylor series is basically used for the linearization. Okay, so that is, let's suppose I have the f of x, any function, and I have to linearize this about any point. So here I want to linearize this system about the steady state point. Then it is my f of xs plus x minus xs divided by 1 factorial f of dash xs plus x minus xs whole square divided by 2 factorial f double dash xs. So this is the series. This is my Taylor series. Okay, it is clear to you. Now I have to find out the linearization of this. Okay, now Q is, I know that Q is my function of h here. Q is my function of h. It is clear to you or not, right? And what is the Q value? Q value is equal to C under root h. So this is the function, and I have to find, I have to linearize this function. Okay, it is clear to you or not? It is clear to you or not? Now, what we have from instead of x, I have the h. That is the difference. I need the differentiation of this function at the steady state point. Okay, so do one thing. Just let's find out the f dash h, means the differentiation of this function. Differentiation of this function. What is the differentiation of this under root h? What is the differentiation? What is the differentiation of? Okay, please don't confuse. I think I should not eliminate any step here. This is my function, and I want to do the differentiate to this function. What is the differentiation of this? It is my 1 divided by 2 under root h. This is the differentiation. Okay, and at what point, at about what point I want to differentiate this? About the steady state point. So this is my steady state. F dash hs is equal to 1 by 2 under root hs. Now whatever you see this series, just put this value. Okay, it is clear to you or not? So just put it. F of x is my c under root h. F of x, this is the function now. F of h is my, sorry, it is my c under root h. So it is my c divided by 2 under root h's. So it is my c under root h is equal to f of xs. So it is my c under root h at the steady state plus x minus xs. It means that h minus hs divided by 1 factorial, it is 1 itself, into f dash hs, that is equal to c divided by 2 under root hs. Okay, done. Now see that this term is h minus hs whole square divided by 2 factorial, and I have to do the double differentiation of this function. Means I have to do the differentiation of this function again. Okay, but my approximation here is this: the value of this function is not that much significant. So my approximation here is this, that I approximate this value as 0. Okay, because that amount is not that much significant. So I have to do only the, you can say the your first you can say the up to the first differentiation, it is okay. So this is the c under root hs value after the linearization. Got it? Got my point? This is the c under root h is the function, and this is the value of the c under root h after the linearization. Now you can do the procedure. You can apply the same procedure as we applied previously. Okay, if I'll write the direct equation, then can I write it, guys, that it is my inlet flow rate minus my outlet flow rate is equal to A into dH divided by D. This is my equation number 1 at any time t. Am I clear with this or not? Please tell me. If you have any problem, you can ask. Okay, there is no need to hesitate. Okay, yes or no, please tell me. At steady state, what is it? QO at steady state minus outlet flow rate at steady state is equal to ADHS divided by DT. Right, this is my equation number 2 at steady state. Right, it is clear to you. Now I can put the Q value here. Right, my Q value is, as we know, that my Q is equal to C under root H. Right, and I have the value of C under root H. I have the Q value. Q value is my C under root H. I cannot put C under root H as directly. So what to do? Just write the C under root H linearized value. So this is the linearized value. So put this value at the place of this Q. So I can write this equation, that I can write from equation number 1. I can write Q naught minus C under root HS minus C H minus HS divided by 2 under root HS. So this is the whole value of Q is equal to A dH divided by dt. This is my equation number 3, let's suppose. And now do one thing, just minus the 3 minus 2. Okay, do just let's increase one step more. And what about the equation number 2? It is my Q at the steady state minus QS. What is the QS? I can write QS as, if Q is equal to C under root H, then QS is C under root HS. Then it is my C under root, this is from 2, and is equal to A dHS divided by dt. And this is my equation number 4, let's say. Okay. You guys are not asking any doubt, but I have a doubt, and please clear my doubt. Okay, I'm saying that I cannot put the c under root h in this equation as directly. I cannot put q is equal to c under root h. But instead of c under root h, I put this value. But in this value also there is a under root hs. Like here also I directly put qs is equal to c under root hs. If I can put c under root hs as directly, then why I cannot put the q is equal to c under root h? Please tell me. My question is clear to you or not? qs को मैंने डायरेक्टली लिख दिया c अंडर रूट एच एस, बट मैं q को नहीं लिख रहा हूं c अंडर रूट h डायरेक्टली. पहले मैंने उसको लीनियराइज किया. Why I could not place q as c under root h directly, but I put qs as c under root hs directly? Why? C under root h is non-linear and linear equation can be solved easily by system. Yes, we know that, Anushka. But actually, I'm asking C under root hs is non-linear or it is linear? C under root h is non-linear. But what about C under root hs? C under root hs is linear or non-linear? Because only I think one difference is there. Instead of h, it is my hs. Instead of h, it is my hs. So isn't it c under root hs is also a non-linear term? Is it so? Is it so? Non-linear, but it is in the steady state. Non-linear, but it is in the steady state. If it is non-linear, then it is non-linear. What you can say? What is the though it's non-linear, the input is not equal to the output at steady state. Guys, क्या सोच रहे हो? How you are thinking like this? Why you are thinking like this? C under root hs is non-linear. Why it is non-linear? C under root hs is a linear. It is not linear even. It is my constant term. C under root h. H is my height of the liquid level and that can be vary. So h is my variable, but hs is a fixed value. Height of the tank at the height of the liquid level at the steady state will be a constant number. It may be 10, 12, 15, 20. Okay, so it is constant. It is a constant term. Even not is in the, here is a not even variable. You cannot say it is linear also. Linear means if there is any variable here, then you can say that it is linear or non-linear. That is a different thing. hs is a number. Height is a height at the steady state is a constant number. So it is non-linear, it is not non-linear, and it is not linear. It is a constant number. It is not comes under the category of linear and non-linear. Linear and non-linear means that there is a variation. There is a variation. Okay, that's why I put C under root hs directly. Okay, please just you can say ऐसा सोचा करो, ठीक है? मैथमेटिकली भी आपको ये चीजें फंडामेंटल्स क्लियर होनी चाहिए ना. Okay, now I can subtract 3 minus 4. I can do this step. the equation 3 minus 4, right? So this is my Q naught minus QoS, that will be Q naught minus C under root HS plus C under root HS will be get cancelled. Okay, clear? Minus C, and this is already in the division variable, so minus C capital H minus C capital H divided by 2 under root HS is equal to D, this minus, that is equal to A D H divided by dt. Okay, this is my equation number 5, right? Now you can guys, yeah, ठीक है, laptop charge. Okay, now do the Laplace. Task is about to complete. Laplace, after taking Laplace, Q naught S minus C divided by 2 under root HS is a constant term, and the Laplace of H is HS is equal to A S H. Okay, now I think I can write this. Q naught S is equal to, can take HS as a common, then it is my AS plus C divided by 2 under root. Okay, output divided by input is that, so I can write HS divided by Q naught S, that is equal to 1 divided by AS plus C divided by 2 under root HS. Okay, yes, it is clear. It is clear. So now I think do one thing, just multiply. You can what to do? What to do? Can I write this? Tell me. The transfer function is equal to 2HS divided by C divided by A into 2HS divided by C plus 1. Please tell me that it is clear to you or not. Please tell me that it is clear to you or not, and if you will say, then I can write on the clear page, that is 2 under root HS divided by C divided by A into 2 under root HS divided by C S plus 1, because I have to convert this into the general format. So in the general format, this plus 1 should be there. This plus 1 should be there. Okay, this plus 1 should be there. Correct? Correct or not? Correct or not, right? Okay, now the next process is simple. Just compare with the general transfer function. Then I can say my Kp is equal to 2 under root HS divided by C, and my tau p is equal to A into 2 under root HS divided by C. Okay, it is clear to you? It is clear to you, right? Now here, this is my resistance term. So my tau p is equal to A into the R, and my R is this. This is my resistance term. Okay, this is my resistance term. Okay, so if you have the known linear wall is there, and if they'll ask to find out the Kp and tau p, then just you have to remember this transfer function. You have to remember the value of Kp and tau p. Okay, and also there is no need to remember the value of tau p, because see, my tau p is nothing but it is my A into R. My R is Kp, Kp is equal to R, we know that in the liquid levels tank. Okay, so whatever the Kp is, that is your R value. So just remember the Kp, and automatically if you multiply the Kp as A to the A, then it is your tau p. Then it is your tau p. Yes or no? Okay. Okay. So let's try to solve this question, guys. Let's try to solve this question. Let's try to solve this question. A liquid level system such as this in the figure has a cross sectional area of 3 feet square. Means I have the area is my 3 feet square, and this is the wall and this is the resistance of it. Okay, qt input ht, okay, the whatever it is. Now here it is my outlet flow rate, q is directly, it is into basically 8 under root h, and this is in the form of c under root h. Okay, so here my c value is equal to 8. Yes or no? C value is equal to 8. My from this expression, c value is my 8. Calculate the time constant for this system if the average operating level above the valve is my 3 feet. Let's suppose it is my 3 feet. Above the wall, it is my 3 feet in the first case. Okay, so I have to find out the time constant. What is my time constant, guys? Time constant is my A into R. What is the R value? Whichever the Kp, that is your R. That is your R. What is the Kp? Kp value is my 2 under root Hs divided by C. C is already given to you. If I have the Hs value, then I can solve this question. What is the Hs value? It is given in the question already. If the average operating level above the wall is 3 feet, means that on an average your 3 feet is the height. It means that it is talking about at the steady state. So at the steady state your height is 3 feet. So Hs value is 3. Put this value. Kp is equal to 2 under root 3 divided by 8. So it is my under root 3 divided by 4. I put the value here. What is my tau p? Tau p is equal to area given to you, that is 3, multiply by Kp, that is 3 under root 3 divided by 4. This is the tau p for the A. For the B, for the 9 feet, for the B option, my tau p is equal to area into R. R is my 2 under root Hs is my 9 divided by C is same. So it is my 339. It is my 9 by 4. Yes or no? Clear? Clear with this? Clear with this or not? Please tell me. Clear with this or not? Clear with this or not? Okay. Okay. Now please put the heading effect of parameters on the first order system. The examples of the first order system is now done. Okay, and now I have to discuss only one or two topics on the regarding the first order system. Then after that we will jump to the second order system. Okay, so you can solve the PYQs based on the first order system, right? You can solve those questions based on the first order system, and you can ask the doubt. You can ask the doubts. Okay, now let's try to understand it. Okay, so to understand the effect of parameters means I have the only two parameters. One is my Kp and one is my tau p. In the first order system I have only the two parameters, Kp and tau p. So with the help of comparison between two first order tanks, we will try to understand the significance of the tau p and significance of the kp here. Okay, and let's take the example of the liquid level example. Okay, so my first case is, let's suppose this is my tank 1, this is the input, and this is my output. This is the height h. Okay, let's suppose the area of this tank is A1. Okay, done. And the resistance offered by this wall is my R1. I have the another case. Not clear? Yeah. XY, please first of all put your name on your username so that I can address you. Because it's I think not sounds good if I'll say what is your doubt XY. And multiple times I used X and Y in the examples, so it is difficult for others also. Please put your name. Please put your name and tell me what is your doubt. Please tell me what your doubt. What is your doubt? Please tell me and put your name. Please tell me your doubt. Okay, please share your doubt. Okay, and meanwhile I'll move forward. I make the second tank. Okay. Now let's understand this problem. Okay. So this is my tank 1 and this is my tank 2. The resistance offered by this wall is R1 and the resistance offered this by wall is R2. Okay. So I am taking case 1 where the area for this is A2. Okay. If let's suppose my area of the tank 1 will be greater than the area of the 2 and the resistance for the both the cases will be same. Okay, will be same. Okay, now I have to figure out, or you can say I have to compare the fastness about the systems, that this system is fast or this system is fast. Let's suppose this is my h1 height and this is my, let's suppose, h2 height. Means this system get its value. Okay, both the values h, both the system, that let's suppose I want to say that fastness means that which system gets its desired value first. Okay, what is the meaning of fastness? If I will say that my system 1 is fast as compared to the second one, it means my system 1 gets its steady state value fast as compared to the tank 2. Fast means that it gets its steady state value in less time as compared to the tank 2. We have two parameters, tau p and kp, and I already discussed about it that tau p stands for the fastness. Means tau p will give you the idea about the fastness, and your kp is basically give you the idea about the ultimate gain. What is the tau p of this system? Tau p is equal to area into the capacitance into the resistance. For the tank 1, what is the value of tau p1? Tau p1 is nothing but it is my A1 multiplied by R1. And what is my tau p2? tau p2 is equal to a2 r2. Because r1 and r2 are same, the product value is depend upon the a1 and a2 value. If a1 is greater than, then I for sure I can say that my tau p1 is greater than tau p2. Right? Yes or no? I can say that my tau p1 is greater than tau p2. Means time constant for the tank 1 or system 1 is greater than the time constant for the tank 2. It means, please pay attention to my words, it means that tank 2 will reach its 63.2% of its UVR in less time as compared to the tank 1. So for sure that tank 2 will achieve its 100% of the UVR in less time as compared to the tank 1. So I can make a statement that my system 2 will be faster as compared to the system 1. Yes or no? Are you able to understand this? Are you able to understand this? Yes or no, guys? Yes or no? Are you able to understand this? It is clear to you or not? It is clear to you or not? Please say, Yanushka, Askar. If I'll make the graph of it, then what is the graph? In the tank system, we know that Kp is equal to R and there is a tau p term. Okay. So my output is my height only. So let's suppose I'll write it in the YT output and this is the T. Right? Okay, I'll repeat it. I'll repeat it. See. This is my tank 1, its area is A1, tank 2, area is A2, resistance offered by this wall is R1, resistance offered by this wall is R2, and they have to, basically I have to compare these two systems. Let's suppose case 1 is my area of the tank 1 will be area of the tank 2 and the resistance are equal. Resistances are equal. I have to find out that which system gets its ultimate value of response first. Which system gets its UVR ultimate value of response first, which gets the first, which gets in the less time, that system is called as a faster. जो पहले रेस खत्म करेगा वही तो विनर होगा, वही तो फास्टर होगा. Yes or no? The one who completes the race first, or you can say in the less time, वही तो विनर होगा. That is here's the same case. Okay, the system which can get its ultimate value of response first, that will be faster. Fastness of the system we will check with the help of the tau p. That is my time constant. And my time constant is equal to multiplication of area into the resistance. So I calculate the value of tau p for each system. For the tank 1 and tank 2, I get A1 R1. For tank 2, it is A2 R2. If you will see this product, R1 and R2 is same. This product value is totally depend upon the A1 and A2. If A1 value is higher than A2, then it is so obvious that A1 R1 product is greater than A2 R2. It means my tau p1 is greater than tau p2. It means the time constant for the tank 1 is greater and tau p2 time constant is less. It means that tank 2 will get its ultimate value of response in the less time. Okay, it's a less time. It means that if it is gained, it is achieved its UVR first, or you can say in the less time, then it means my tank 2, or you can say my system 2 is faster as compared to the 1. As compared to the 1. Okay. Okay, great. But please put your name. है ना? Put your name. मैं समझ नहीं पा रहा हूँ. Please put your name on your username. Right. So this is it means the system 2 is faster as compared to the system 1. Okay, I'll discuss this topic in the next class. Okay, guys, because this topic takes some time. Okay, because we have 3 to 4 cases and I have to define a different graph of it, and after that we will solve some questions based on it so that you will get all the points. Okay, so that's it from my side guys for the today's class. Let's meet in the next class. कल class लेते हैं, कल यहीं से इसको resume करते हैं. Yes, this is case 1. I have assumed that A1 is greater than A2. Okay. टैंक एरिया तो मुझे पता करना पड़ेगा ना, मतलब टैंक एरिया तो मुझे क्वेश्चन देगा. क्वेश्चन विल गिव मी दिस, द टैंक एरिया इज, व्हाट इज द रिलेशन बिटवीन द टैंक एरियाज. दिस इज आवर assumption. This is the case if A1 is equal to A2 and R1 is equal to R2. This is not we calculated. This is we assume that if it is this case, then what will happen. Any other doubt? Any other doubt? Done? Done? Any other doubt? Okay, great. Then bye bye. Take care. Let's meet in the next class. Bye bye, guys.